Welcome to 7.1, Area Between Curves, Day 2. So I want you to take a look at example 1, the accumulation function, meaning as x is getting bigger, this function is changing. The area underneath that curve is changing, and that's what it's looking at. It's looking at the integral, okay? So what I want you to do is I want you to take a look at that and look at the graph here and try to go ahead and fill out the values of f of 0, f of 2, and f of 5. One hint, as you're going through, you can look at it in terms of trapezoids, right? Because we've got trapezoids here if we're starting at x equals 0 and x is getting bigger and bigger. So take a look and see how you do. Okay, so hopefully you recognize, when x is 0, we're essentially looking at the integral from 0 to 0, right? And we know that that is going to be 0, okay? Now, if we found f of 2, we could again look at it in terms of the trapezoid. 1/2, the height is going to be 2, that x value, and then the sum of the bases, all right? Now, if we were looking at it in terms of the integral, okay, you would integrate from 0 to x of 2t plus 1, and integrating 2t plus 1, you get t squared plus t, but evaluating it from 0 to x, we would get x squared plus x. So if x is 2, then it would be 2 squared plus 2, and we would get 6 as well. So there's kind of two ways you can look at this problem. For f of 5, again, if you looked at it in terms of just the area of the trapezoid, you would get 1/2, the height is 5, and the sum of the bases, 1 plus 11. You would get 30. If you were looking at it in terms of the integral, right, x squared is 5 squared plus x, which is 5, and we would get 30 there. This next example is finding the area of the region bounded by the graph of y equals x cubed minus 2x and the tangent line of that graph at the point -1, 1. So the first thing we have to do is understand what what's our bounded region that we need to find the area for. And in order to do that, our first goal would be to find the tangent line, okay, because it's bounded by the tangent line and that function. So to find the tangent line, we need to take the derivative of our function, evaluating at the point -1, 1. We get the slope of our tangent to be 1, so the equation of our tangent line through the point -1, 1 is going to be y equals x plus 2. Okay, so what I want you to do right now is I want you to graph this situation. Graph the function y equals x cubed minus 2x, graph your tangent line, all right, and then see what that bounded region is, all right? Don't find the area yet, just see if you get the graph. Okay, so hopefully you were able to graph this, our tangent line through the point -1, 1, all right, and our function of y equals x cubed minus 2x is going to look something like this. So the area that we're trying to find is this guy here. Now, how did I find these points of intersection? Well, that's what we need to do next. So let's verify the points of intersection right now. So in order to do that, we need to set our tangent line equation equal to our function, y equals x cubed minus 2x. So doing that, we get this cubic function. Now, without the help of our calculator, how would we do this? Well, we know that they intersect at the point -1, 1 because that's our tangent line, right? So we can use that fact, the x value is -1, and we can remind ourselves about that synthetic division. Remember, I need a placeholder for the quadratic term, so there's 0x squared, all right? We drop the 1, we multiply, add, multiply, we get a remainder of 0. So we're left with our quadratic function, x squared minus x minus 2, which factors nicely, and we get our 2x values. So when x is 2, we can throw it into our original function, and we get y is 4. And when x is -1, we know y is going to be 1, because that's our point of tangency here. So we're able to get our intersections. So this is going to help us now. And now what I want you to do is I want you to find the area between these curves. Remember, if it helps, go ahead and draw in our rectangles, okay? And remember, it's top minus bottom if that portion represents our dx, okay? So set up your area formula, check back when you're done. Okay, so hopefully you were able to see that area is we're going to integrate from the x values of -1 to 2, and it's going to be our top curve minus our bottom curve. So that's our tangent line minus our original function. So x plus 2 minus x cubed minus 2. Make sure to use parentheses around that second function. All right, and as we continue on, we could go ahead and integrate this, cleaning this up and gathering our like terms. We're really integrating from -1 to 2 of -x cubed plus 3x plus 2. Go ahead and verify that in the end, you end up getting the area to be 27/4. If you have any questions on this, let me know next time we see each other.